Alright, so section 6.3, graphing to solve systems of linear inequalities. It looks like we skipped section 6.2, which we have. There's really no point to do it because it's not even really a section and it doesn't really cover anything. And everything that's covered in 6.2 is covered in 6.3, so I'm just skipping 6.2. Alright, so what does a region look like? So you'll be graphing two sets of lines and shading what's called a region. First thing we need to do is we need to look at the red line and we need to say, okay, -2 is my y-intercept, so I put a point. 2 over 1 is my slope, positive slope, so I go up 2 over 1, up 2 over 1, up 2 over 1. Or I could also go back down 2, back 1, down 2, back 1. Once you have your points, take a ruler, draw a line, straight line through your points. There. The next line, my y-intercept is at +1, so I go up to +1, and that's my first point. And now my slope is negative, and it's 1 over 3. So I go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Or I could have gone up 1, back 1, 2, 3, as long as it has a negative slope. Once I have that line, then I can again use my straight ruler, make sure that my points are all, see here, make sure my points are all lined up, so they are, and then I draw a straight line through them. What did I do there? 1, 1, 2, 3, 1, 1, 2. See, I made a mistake already. So the top point wasn't quite in line. 1, 2, 3. I didn't go over far enough. Now, they should all line up. Yes, they do now, finally. Okay, so I draw my straight line through. And what happens now is it actually splits the whole graph up into 4 regions. There's one region at the top. There's another region over here, a third region down here, and a fourth region on the left there. So regions are basically where the lines cut into sections. How do we know what region is being asked for? Well, it totally depends on the question. So these are the same two equations from above, only this time I've added inequalities so we can figure out where to shade. Again, same lines as above, so my y-intercept of 2 and up 2 over 1. Notice that if I don't have a number underneath, you can always put it over 1. Up 2 over 1, up 2 over 1. Do this quickly here. And then my next one is at +1, and I go down 1 over 3, down 1 over 3, down 1 over 3, up 1, back 3, up 1, back 3. You see there, did I do something wrong? Yes, that last point. Okay, get your ruler out, draw straight lines through each of them. Now, is it going to be solid or dotted? Solid because I have an equals to on both. So both of them are going to be solid lines. Otherwise, I would have to dot the line. Okay, and the next line goes up. There we go. So now I have my two lines, and we have to figure out where to shade. Well, this one says greater than or equal to my red line, and greater than or equal to means above. Greater than or equal to, again, whoops, above. Sometimes it's kind of hard to figure out, well, where is above the line? But I can kind of know, well, above the line is going to be up here, below the line is going to be down there. So I shade above. You can probably see what region it's going to be in right now. I shade everywhere above. The other one I also shade above. So below would be down here, above is up here, so I shade above. Where the two colors intersect is basically where the region, oh, what happened there? Is basically where my region is. So I'm looking at this region right here. Okay, so that's the region that's being asked for, is the region right there. And what you would probably do is you wouldn't shade everywhere. You'd probably only want to shade where you're supposed to shade. So I'll use green to shade, and above on both lines is actually this region right in here. Okay, that's the region above both lines. Remember how I showed you how it cuts it into 4 regions? Well, we're in region number 1, above the red line and above the yellow line. And what you can do is you can actually check. Just test a point to make sure. So what you do is you pick a point within your region. Doesn't matter which point, any point will do. So let's pick the point, it's easy to have 0 as one of the values, so 0, 1, 2, right there. So we're going to test a point, 0, 2, all right? 0, 2. And I plug that into both equations to make sure that it actually works. So the first equation, and remember that's my y value, and the first one is my x value. So I test. Is 2, which was my y, greater than or equal to 2 bracket 0, which was my x, minus 2? Plug it in. Is 2 greater than or equal to 2 times 0 is 0, minus 2 is negative 2? Is it? Yes. So it works, it checks out. Now we have to check in the second equation. Again, same point. I'm plugging 2 in for y, greater than or equal to negative 1/3, and I'm plugging a 0 in for x, because I picked a point that was within my shaded region, plus 1. Is, and we should really put a question mark at the end of that, because we don't know yet. So is 2 greater than or equal to negative 1/3 times 0 is 0, plus 1 is 1. Is 2 greater than 1? Yes. Therefore, I know that I've shaded in the correct region, because the point in that region checks out for both. And you only have to check one point if it says test a point. But you have to test that point into both equations. All right, let's try one more. What if it's written like this? Oh no, I don't like this form, but that's okay. So xy just tells you that it's a coordinate point. Oh no, I have 2x plus 2y less than or equal to 6. It's not in a form that I'm used to graphing, right? It's not in a form that I'm used to graphing. But remember, there's different ways to graph. Some people really like to get this in y equals mx plus b form. So if I do that, I get 2y less than or equal to, I subtract my 2x on both sides, subtract 2x, minus 2x. Remember, I don't switch the sign. I only switch the sign if I'm multiplying or dividing. I'm just subtracting this time. Plus 6. Next, I divide by 2. So get rid of my 2, divide by it. Divide negative 2 by 2, you get negative 1x. Divide 6 by 2, and you get 3. Remember, you have to divide everything through. So I've converted my equation now to an y equals mx plus b form, and now we can graph this, right? Y-intercept at 3, 1, 2, 3. It's probably a good idea to do this anyways. I mean, you can graph them other ways as well, but this is nice because then you know if it's above or below. And my slope is negative 1. Remember, I can put anything over 1, so down 1, over 1, down 1, over 1, and so on. Then once we have our points, we draw our line with our ruler. Whoops, that's okay. And my second one, again, I'm going to have to change this. Well, you don't have to. It's a bit easier though, because again, you can figure out where to shade. X minus 3y less than or equal to 6. So again, I can move, take the x over, minus x from both sides. So I'm left with a negative 3y is less than or equal to negative x, because I just subtracted, plus 6, because that's a positive 6, just like above. Now, I have to get rid of the negative 3, so I have to divide by it. But that means that this is going to flip. So I divide by my negative 3, divide by my negative 3, but this has to flip. Okay? So what happens is the 3's are gone. I'm left with y greater than or equal to, and then x, negative x over negative 3 is a positive 1 over 3, or x over 3. And then minus, because 6 divided by negative 3 is a minus 2. So you gotta be really careful when you're dividing by a negative to flip the sign, because it's going to totally change your region. And be very careful that you divide each term by that denominator, by the 3. Negative 3, negative 3. So my y-intercept is at negative 2. Whoops, sorry about that. My y-intercept is at -2, and my slope is 1 positive 1 over 3. So up 1 over 3, up 1 over 3, up 1. Whoops, it's only over 2. I always get messed up. Okay, up 1 over 1, 2, 3, 1, 1, 2, 3. Good idea to count. Down 1, back 1, 2, 3, down 1, 3. Alright, so I got my line there. I draw it. It is shaded, or it is straight. It is solid, not dotted. Remember, it's only dotted if that sign says less than or equal to or greater than or equal to. Notice this time that I have y, e, I. Whoops. And xei, sorry. Y, e, I, and xei. I'll just note that right here in red. Also down here, xei and yei. That means that when I'm shading, I'm not going to shade everything. Only put dots. Remember that from the last section. Now, where do I shade? Okay, well this one is below my green one. Below the green one. So everything down here. Everything below the line. The black one, though, is everything above. Everything above the black line. So where the two intersect is actually right here. So now I get rid of those two, and I know that my region, I'll use yellow, is going to be right here. But do I shade? No, I don't shade. Because it's y, ei, and xei, I only put dots in the region. That makes sense, right? So you put dots in the region to show that only integers are allowed. Nothing in between those dots are allowed. If it was yer or xer, then you could shade everywhere. But since there's only integers allowed, I only put dots. And I'll quit there for now. But you get the idea. So all the dots are included. Oh wait, but it's actually less than or equal to or greater than or equal to. So I can actually have on the line as well because it can be equal to the line. That's important too. So the line, the dots on the line are included as well. Okay? Now let's test a point. Well, we have tons of points here. I usually like to test a point that's in my region that's on an axis. Look at that, 0, 0. That point right there, 0, 0, is in my region, and it's an easy one to check. So in the first equation, I have y less than or equal to -1 x plus 3, and I plug my point in, is, and that's my y and my x. So y is 0, x is 0, so I plug a 0 into y, is 0 less than or equal to -1 times 0 plus 3. Is 0 less than or equal to 3? Yes. Therefore, I've done that one right. Now let's test it in the second equation, in the black one. So y greater than or equal to 1/3 x minus 2. Again, I'm using x for 0 and y for 0. So 0 is 0 greater than 1/3 times 0 minus 2. Whoops. Is 0 greater than or equal to 1/3 times 0 is 0, minus 2 is -2. Yes. Therefore, that checks out. Both of them check out. Therefore, I know that I've shaded in the right spot. Keep in mind that it was xei, yei, so that means that I only do integers, which are only points, so I don't shade the region, I just have dots. Or if you see a graph that just has dots, you know right away that it's just going to be ei. If you see it shaded in like the one before, you know that it's going to be er. Or it's not, that one wasn't specified. But most of the time they will say er or they will say ei. And testing a point, make sure you pick a point within that region and plug it in. And that's it for section 6.3.